Good morning all. Welcome to the video lecture for the subject Artificial Intelligence, Introduction to Artificial Intelligence for first year students. I am Dr.M.Hemalatha, Professor, CSE Department, RMDEC Engineering College. This lecture is the continuation of the previous video lecture for the topic Production System. We have already seen the definition, applications, 4 key components and 4 features. In this lecture, we will continue with the next part of the production system, which is my control strategy. Before getting deep into it, I'd like to re-insist the definition of the production system. Production system is a type of computational model used in artificial intelligence to simulate human problem solving and decision making process. It consists of a set of rules, a knowledge base, and a control strategy to achieve specific goals. Getting into the control strategy of production system, let us have an overall skeletal understanding of the concept. I have artificial intelligence system which is helping me to solve the problem, and that is done through my production system. The production system is supposed to make decisions, and these decisions should be made in a very effective way. For this to be done effective, it results in efficient working of it. For it to be efficient, what is required? Two things on the broader level is required. One is control strategy, two is search strategy. In this lecture, we will be concentrating on control strategies. Control strategies are crucially influencing the AI production systems. Why? Because they guide in making decisions or for deriving conclusions. It plays a very important role, essential role in efficient decision making and problem solving. So when can you brand a control strategy as a good control strategy? It is supposed to have certain requirements. So what are those requirements? It should cause motion, meaning it should change me from one state to another state. It should progress towards the goal from the start. And it should be systematic and it should be efficient for finding out a good answer. So how can this control strategy influence the reasoning process? It comprises of 4 important parts. One is rule selection, 2 the order of execution, 3 the efficiency, and finally the goal achievement. So what is rule selection? You will be determining which production rule has to be applied based on the current state and also considering the goal state in your mind. Order of execution is the sequence of rules that are getting applied. Here, as we have seen previously, is this going to be goal driven or data driven? It could either follow forward chaining or backward chaining. Coming to efficiency, it aims to optimize the reasoning process. When you optimize the reasoning process, you are sure to reach efficiency. Why? Because you will be minimizing unnecessary rule applications and you will avoid redundant calculations. Certain calculations which gets repeated can be avoided if you go for optimizing the reasoning process. And this is very important state, the goal achievement state. Here you will have the reasoning process that aligns with the system's objectives. You have to find a solution. You will be making a decision whether you have reached the specific outcome. Only this decision will tell us whether we have reached to the final or are we somewhere in between and we have to still proceed further towards the goal. And how could this be done? For this to be done, you have to have certain strategies to be followed. So, on the whole, for you to achieve goals, what are all the key strategies that could be adapted? The broadly classified strategies are DFS, depth first search, BFS, breadth first search, best first search. This is breadth first, this is best first. Rule ordering and priority, parallelism and concurrency. So what you do in DFS, you do a sequential search. Here, this sometimes can give us suboptimal solutions. It always gives a solution. Sometimes it gives a suboptimal solution, and it can become suboptimal due to deep paths that it is going to take from the start state to the goal state. In BFS, breadth first search, it is doing level by level systematic exploration. This process, this strategy ensures completeness, and of course it is going to require additional memory. Best first search chooses the best paths. Best paths are the ones which have good heuristic values, and it aids in making informed decisions. Rule ordering and priority is a configurable strategy. It determines the sequence or the priority of the rule execution. For parallelism and concurrency strategy for achieving the goal, it executes multiple rules in parallel, hence improves performance. It follows rule-based frameworks, and it is basically set of conditions and actions. Please remember, in production system, productions refers to simply, in simple terms, actions. The actions that are used to derive conclusions. The entire effectiveness of it can be achieved through two inference rules. It could be either deductive inference rule or abductive inference rule. Deductive inference rules are logics that are used in AI and knowledge-based system which facilitates you for deductive reasoning. It means it involves drawing specific conclusions from general premises or facts. Premises or facts are the one which is already in existence. And in deductive reasoning, the conclusion is guaranteed to be true if the premises are true and the influence rule is valid. So based on the starting point, your ending point is decided. Modus ponens and modus tollens are the common deductive inference rules that are helping for us to derive valid conclusions from the given facts and rules. Coming on to abductive inference rules, they are used in AI and reasoning systems to facilitate or to make educated guesses or hypotheses based on the data that is observed or the evidence that is observed. Unlike the deductive inference rule, abductive conclusions are not guaranteed true. Here, the conclusions are not guaranteed true but are selected based on the likelihood given the available evidence. Likelihood refers to the probability. So, given the available evidence, based on the likelihood of the available evidence, right, abductive conclusions can be reached. Abductive inference is particularly used in situations with incomplete or uncertain data where the system needs to make possible guesses or explanations. With this, we end the video lecture 5. Thank you.